Hi, I'm Roy Murphy. You're watching the Bitconnect YouTube channel. Coming up in today's video, the Bitconnect Codebase. Hello everyone, I'm Roy Murphy. Welcome back to the Bitconnect YouTube channel. Today is a follow-on video from the last technical video that we did, looking at quite a low level of how the Bitconnect platform works. Today we're going to be digging a little deeper. We're going to get a bit more technical, and what we're going to be doing today is digging into the wallets, the nodes, the actual coin itself, where it lives, how it works in detail. So this will be a good one, whether you are technical or not. Try and keep up with me. And as usual, we have to put everything into context. Now, this video will be a prelude to the final video, which will be showcasing the trading bot. And it's something that you guys have been asking for, you've been voting for, you've been asking me loads and loads of questions. Now, that process is going to be very, very difficult without some serious hardware. Now, I've got the hardware and we will be doing that video very, very soon. What I need to do, first of all, is to give you some background history into what I do, what I've done, how I know certain things, because I get lots and lots of technical questions about the system. I get over 500 emails a day, and I get lots and lots of YouTube comments, and we do answer, or we try and answer all of them as openly and honestly as possible. So what we will be referring to, and what you've probably heard me over the last few months refer to all the time, is community. Now, when it comes to community, there is nothing better for the developmental world for computing than this guy here, Linus Torvalds. Now, I had the honor of meeting him about 12 years ago, and we're going to be going on a journey of all the people that are either advertently or inadvertently involved in Bitconnect. And that goes the same for Bitcoin as well, because Bitcoin and Bitconnect would not exist if it wasn't for Linus Torvalds. Now, Linus is a brilliant developer. I've had the honor of meeting him and discussing certain computing aspects with him. I will also have the honor of meeting him on the 28th of November. Now, I'm giving a talk at the Blockchain Summit in London on the 28th of November. And he's very, very shy. He doesn't usually get up and do lots of public speaking, so I have been put on a table with him for the after dinner party, so I will be able to grill him over everything that I've missed out on the last 12 years. Now, he is probably one of the most misunderstood people in the programming world. Now, if you don't know who Linus Torvalds is, Linus is the creator of Linux. Now, if it wasn't for Linus, you wouldn't have Android, you wouldn't have Mac OS, OS X, you wouldn't have Apple, you wouldn't have Raspberry Pi. There are so many things you wouldn't have. We talk about forks all the time in the altcoin world. You know, there's a fork of Bitcoin. You've got Bitcoin Gold, you've got Bitcoin Cash, you've got SegWit 2x. You've got all of these different forks. Forks were created in the mind of Linus Torvalds. So we must pay respect to this guy for his work, and we need to go through the history of some very important things that have happened in computing to realize the effect that they've had on everything that we do today in Bitconnect. Okay, so Linus Torvalds. So I'll be having a good chat with him next week. So the reason why we met originally, I was a big proponent very early on of the Fedora project. I worked on it from day one. Have done for nearly 20 years. I stopped about 7 years ago. So this is the operating system of choice out of all the different repositories for Linux that Linus Torvalds uses on a day-to-day basis as his personal computer. Because it's based on the Linux protocol, it's based on that distribution. So I spent a long time working with Fedora, which is why there's an association between the two of us. Now, for a long time I worked with the Red Hat Corporation. So Red Hat is a Linux enterprise server system. I spent a long time working with Red Hat, and part of the Fedora project, you notice that the Red Hat icon is actually a Fedora hat. The Red Hat was the enterprise Linux server system for big corporations. You can see here it's the reason that 90% of all Fortune Global 500 companies choose Red Hat. It is the system of choice for anyone that can afford to run the Red Hat Linux server. So the Fedora project uses the Fedora from Red Hat as it was the desktop application of the Red Hat group. Okay, so you have the commercial side of the servers, and then you have the operating system, the desktop operating system, which is my preferred distribution if I'm using a Linux computer. So that is that there. So I worked on, later on, there is a community, we keep using this word community, there is a community fork of Red Hat that became a free open source distribution of Red Hat, which later became CentOS. Now CentOS stands for Community Enterprise Operating System. It can either be a desktop computer or it can be a very powerful open source community driven server. There are many variations, there are many forks of CentOS. Trying to give you a little bit background history. The reason why CentOS and Linux all derive from a 1970s multitasking, multi-user computer operating system called Unix. And there are two very, very big key people that took Unix to the next level. Okay, AT&T being one of the biggest companies, they partnered with a guy that I'm sure you know, Steve Jobs, to later on create the very early versions of the Apple Macintosh. Okay, so Unix, that is the background for a lot of these systems. Now if we go, you'll recognize Steve Jobs as the, there you go, there he is with his iPhone. If it wasn't for that, you wouldn't have Linux today, and you wouldn't have Mac software and Android and all these other wonderful things that we enjoy today and take for granted. So from smartphones to cars, supercomputers to home appliances, the Linux operating system is everywhere. Linux has been around since the mid-90s and has reached a user base that spans industries and continents. For those in the know, you understand that Linux is actually everywhere. It's in your phones, it's in your cars, it's in your refrigerators and your Roku devices. It runs most of the internet. The supercomputers making scientific breakthroughs and the world stock exchanges all use something that's based on Linux software. But before Linux became the platform to run desktop servers and embedded systems across the globe, it was and still is one of the most reliable, secure and worry-free operating systems available. Okay, so just like Windows XP, Windows 7, Windows 8, Windows 10, Mac OS X, Linux is an operating system. An operating system is software that manages all the hardware resources associated with your desktop or laptop. Now we'll skip most of this. We'll talk about the big pieces that happen in Linux, in Unix style operating systems, of which if you have a Mac, MacBook Pro, or you have an iPhone, anything with the word I in front of it, basically have all of these things. They have the bootloader, which is the software that manages the boot process. You have the kernel. Now this is something that Linus Torvalds has spent nearly more than 20 years developing the Linux kernel, which is Unix based. Okay, it's the piece of the whole that actually is called Linux. The kernel is the core of the system and manages the CPU, memory and peripheral devices. The kernel is the lowest level of the operating system. So if you think of everything as a pyramid and you think right at the top is your screen, the output, or the graphical user interfaces and everything, the kernel is the bit at the very bottom. It's the building blocks of everything. This is also important. Daemons. Daemons with an A, they are the workers. These are the background services, the printing and the sound and the scheduling and everything, all the crons that are either started up at the boot or after you log into the desktop. You also have the shell, so you have shell scripts. It's a command line process that allows you to control the computer via commands typed into a text interface. There are other levers. You've got the graphical server, desktop environment. You can have a KDE environment or GNOME. I know it looks like GNOME, but it's actually pronounced GNOME. Many others. And these are all the different flavors of repositories of user interfaces that are built on top of Linux. Okay, there's lots of different applications. So let's talk about one particular version, one distribution of Linux, and this is an old version. This has been around for more than 30 years. This is called FreeBSD. Now FreeBSD isn't actually very popular today. I'm not a big fan myself, but if you look at the history of what FreeBSD became later on, now there was a fork. We keep talking about forks and community. There was a fork of FreeBSD Now, when Apple came out in before it was actually registered, when Steve Jobs was working on the original Mac, it was based on Unix. They took that Unix software and he made, in his garage, I think he was selling, it was CPUs integrated into very, very simple motherboards, and he sold them at wholesale from his garage. This is how, the whole Apple entity started, from someone's garage. So it wasn't until 1985 that he used the Next operating system, which later, after he left and he joined, I think he joined Disney. I think Steve Jobs ended up going to Disney and working on what later became Pixar Animation. So in his time away, the powers that be couldn't find the Next operating system, Next as in NEXT OS, which was basically powering Apple Macintoshes of the day, and they ended up, whilst he was away, integrating FreeBSD, a distribution of Linux that later became Mac OS X, or Mac OS, which later became OS X and all the other versions of Mac. The iPhone and the iPod and the iMac all owe their history to FreeBSD, and FreeBSD owns its history to Linux and its history to Unix. So there is all these people involved, and you can see the history of how things are improved. Now, Mac OS X, if you think about Mac, it's just a really, really pretty reskin of something that was always free and open source. Open source only exists because of Linus Torvalds. And even today, he could have monetized it and made himself a multi-billionaire. He could be one of the richest people in the world, but his drive is to build communities. He understands the power of people working together for a better cause. This is why, for me, he is one of the most important developers, one of the most important people in the development world, because of this notion. So that's Mac for you, and you know what Mac powers. It powers everything that is Apple. You have your Mac, your iPad, your iPhone, your iWatches, your Apple Watches, Apple TV, all of the music and everything that Apple is today owes itself to Linux. So something else that Linus Torvalds worked on, and is something that transformed the industry, especially the industry that I work in, when you work with developers, he invented this other thing called Git. Now, Git is a distributed version control system designed to handle everything from small to very large projects with speed and efficiency. So to give you an analogy, what this allows is, rather than different developers using code and then trying to share it via email and take the bits of changes and the improvements and then someone else write that and then push that live, this is a way for people to collaborate on the same piece of code and their own improvements. And there are different version controls of how you pull and push and upload those changes without actually harming the original. So this is a version control system called Git. Now, later on, it was actually part of what later became a Google project, became the world's first online distribution, which was based on Git, and it's called GitHub. Now, GitHub, some of you may have already known, but it's built for developers to communicate and to develop software alongside millions of other developers. So it's a way of communicating and combining and adding your code, your reviews, your analogies, your upgrades to a piece of software, and it is a community project. This would not exist if it wasn't for Linus Torvalds. So let's cut to the chase now. Let's get to the GitHub version of Bitconnect. Now, this is the Bitconnect Coin. So what this is inside this GitHub repository is the community collaboration project of different people over different times. There are different areas of different parts of different libraries that have been merged together to create Bitconnect. If you look here, it says Bitconnect Coin is an open source, peer-to-peer, community-driven decentralized cryptocurrency that allows people to store and invest their wealth in a non-governmental controlled currency and even earn a substantial interest on investment. The Bitconnect coins are used by the Bitconnect community members for Bitconnect services and to store and invest. And it's got the link to the bitconnectcoin.co.uk. This is the official repository. This is the community repository for the Bitconnect coin. And when I say coin, I don't just mean the coin. I mean all the wallets. I mean the instructions for the nodes, for everything to create and to move money, to do all the processes. It has lots of code inside it. We're going to cover some of the code that is inside Bitconnect coin. So I won't go too much into the technicalities because some of you won't be that technical, but it may be interesting for you to actually see how everything is put together and what the history of the libraries behind it are, what their history is. Also look at the contributors, the people that have worked on projects that have been merged into Bitconnect over the years. It isn't just one person, it's not just one developer, this is a community of people working together. I'll show you the repository. So if you look here, you've got the README file, which is in here, and this is what actually gives this text underneath in the README. It says General Introduction of Bitconnect Coin. Bitconnect Coin is a secure and energy efficient proof of work, proof of stake coin. Bitconnect Coin uses a faster proof of work distribution mechanism to distribute the initial coins. Then after a few days, the coin is basically transferred to a pure proof of stake coin, where the generation of the coin is mainly through the POS interests. If you want to understand how the coin is created and how the coins are generated, you need to understand this. If people say, how can Bitconnect ever be sustainable? The answers are in the code. If you don't need to understand code, just understand where to look and draw your own conclusions based on that. So the Bitconnect coin specification states that there is a maximum of 28 million Bitconnect coins that will ever exist in the community. Now we've worked out at that creation rate that will not complete until the year 2146. So I think most of us, if not all of us, will be dead at that point. So worrying about the end times is not something that we need to do now as far as the wallets are concerned, as far as the coins are concerned, as far as the network is concerned, and as far as the distribution of the coins are concerned. So Bitconnect Coin adopt a variable proof of stake rate that will be given periodically payout as per the following list. So in the first 6 months, we've already passed that now. There's a 60% merger at 10% per month, so you get 60% per year proof of stake. Second 6 months, which is the month we are in now, or the half year that we are in now up until the end of December 2017, there's a 50% interest in the stake at 8% per month. In the first half of 2018, it will be 7% per month. Second half of 2018 will be 5%, and then in 2019 will be when the whole system, the proof of stake system, is phased out, where you get 3% per month from January 2019 until June 2019, and then the last half of 2019 you get 10% at 1.4% per month, and then ongoing thereon. So how are they used? The Bitconnect coins are used by Bitconnect community members for Bitconnect services and to store and invest the wealth in a non-governmental controlled currency. The Bitconnect coin will also be used as a payment system on a number of Bitconnect partner websites. Okay, so we can go through how they're produced and how to actually go and download your wallets. I imagine if you're using Bitconnect, you've probably got a QT wallet already, and you can see that everything is called a QT wallet. So all the wallets are called QT. We'll go through the reasons why it's called a QT in a moment. So let's go and dig into some of the code that powers the system. So you can see you've got the main things, which are mainly the install codes. You've got the README files. You have the Bitconnect QT Pro. Now what the Pro stands for is project. Now there is software called QT software. If I go inside the project for a moment, you can see that it is called Bitconnect QT. So QT software is what actually makes all of the different versions for Mac, for Android, for Linux and for Windows. So it is a way of writing it in a specific type of code. In this case it's C++ is the code that's been used to write this, and they use the QT software to actually combine and make a finished, polished version that is executable in different programming languages and for different operating systems. So that is what Qt is. Okay, it's a way of writing code once and then porting it to different operating systems. So that's what this is used for. So there will be a make path. So this is all of the binaries that it's accepting. These are all the external libraries that are being used. So it's not just an internal thing. There are external libraries being used to actually combine, compress and create these finished versions. So you can see all the object paths. If we scroll down, you can see the make targets. I don't want to go too much, but this is the source code under the Qt wallet, and you can see everything ends in .h. So this is the binaries that have been already pre-compressed into a language that the Qt software can actually make. So these are the transaction table model, for instance. .h comes from the transaction table model .c++, so it would be .cpp. So you write it in C++ and everything is then ported so it can be made into different versions for different operating systems. So that's what the Qt part of the Qt wallet means. So all of these are the source codes. These are all of the different models written in C++ that give all the logic so that when they combine all these together and run it as a complete program, it does everything it needs to do. So that is the Qt wallet and the actual daemon for Bitconnect. So it's the Bitconnect QT, and that is the project for the Qt software to be able to build all the different versions for all the different operating systems. So let's go into the contrib file. So you've got contrib, doc, setup, share and src. So contrib are all the different libraries and the contributions. Doc is all the documentations. Setup are all of the binaries that are necessary to actually start the program. Share is what it says on the tin. It's all the different sharing mechanisms and all the different IP addresses used to connect everything together. And the src is the source files. It's where the main application actually lives. This is where the daemon runs, and this is where the wallets and the nodes get run from on different Linux servers all around the world. So let's just jump into the contrib file. So I don't want to go into every single one and give you all the details. It would be a 10-hour long video. So let's just quickly run through this. So we've got Bit RPC. This is the Bitconnect or Bitcoin remote procedural calls. So this is everything for the wallet to actually communicate, and this is the startup. So when you actually install the wallet for Bitconnect, it will create an app data file. So that will run on a different area of your system. So this will be installed. So if it's on, say for instance, it's on a Windows machine, you'll have your installation files. It'll be on your C drive. There'll be it will exist as an application that is executable, but the data that comes out of it is actually held in your app data. So if you destroyed or lost your wallet for any reason, your app data isn't actually deleted, and neither is your history, and neither is are all the transaction histories that it's downloaded from the nodes. So in this case, you can actually update a newer version as they come about, and it doesn't actually destroy any of the history, and everything is backwards compatible. So you can update your wallet, and your transaction history is there, and all of your history from your transactions, your buys, your sells, your storage, your staking history and everything is all there, because it uses the same private key which actually lives in your app data area of your computer. So the first thing it does is JSON RPC, which is JavaScript Object Notation Remote Procedural Call. So this is saying that it's an internal call to this address. So this is the service proxy. This is a local IP address on your machine, and it will open up port 8332 as the communication port to do everything that it needs to do to update that app data. So there's certain functions here. You can see that you've got the backup wallet. It's got an if statement, cmd is a command, equals. There are different integers for equals. Equals actually just means equals. There's equals plus and equals minus, which is a greater than or less than iterator. backup wallet, so it says try, it goes to the path and it says enter destination file path name, and then every action, every function has an exception, and if the exception will actually print an error code. So this is used for debugging. So if something doesn't work within the system when you're developing this stuff, it will say error debug code level 21, so on line 21. If it gets to this stage and then gives you the error code, you know there's something wrong with this text here. So it means you've done something wrong. The developer can then look into it and then fix it. So that's why you have all these elifs. This is an else if statement. So what it's saying is if backup wallet, and then it's going to go through a cycle of all the different functions. So the next cycle is an else if. So if this is a success, it goes to the command get account, and then it goes through enter Bitcoin address. So these are all the different functions within the wallets that it needs to have when it starts up. So it's the actual Bitconnect address, get account address, so this is the account address from the nodes, get addresses by account, so these are the account functions, get balance, this is important if you want to open your application and find your balance in there. So it goes through and looks for the function called get balance. Okay, so these get balance functions are elsewhere within this repository. This is just all the calls that it expects, and if it gets the correct answer back, your application will open. So if there's a problem with any of this, your application will never start. Get block by count, get block count, get block number, get connection count, get difficulty. So this is the difficulty from the miners. This is from the actual network itself. So this is for the proof of work method, so it needs the actual mining difficulty, so it actually gets that from the RPC call. Get generate, we've got all sorts, get info, get new address. So your addresses are actually created and obfuscated inside your app data within your PC. So you don't need to know all of this. It's just I want you to understand how complex some of these can be. This is just one simple call file to a set of functions. And you can see how many functions there are that it needs before it even opens the application. So you've got get transaction, get work. We've spoken about this in when we did our mining video. When you want to do mining, obviously you need to find the get work procedural call that will give you the hashed algorithm for you to actually mine, understand with the difficulty rating, and then actually do the decrypting, do the hashing, and then send it back for the network to see if you've got the correct answer or not. So that is the get work. We won't go through all of these, but this is basically the Bit RPC file. So that is one of the main files. Go back to RPC. Let's go back to the contrib file. The next folder is called Debian. Now, if you don't know what Debian is a repository. It is a variation of one of the Linux distributions. Debian, the reason why that it's got Debian in here is because it's the type of server and all the libraries that are needed, necessary for this particular coin, for the Bitconnect coin to run, requires all of these prerequisites that exist in all of these different source files and patches, and these are all different updates and libraries that will allow the coin to have everything it needs to communicate with its end target, which is the node. Okay, so you've got copyright things and you've got bins and examples, so I won't go through all of these, but something that is interesting, it's calling the Novacoin QT desktop and the install areas for Novacoin. So if you want to know what Novacoin is, if we go to Novacoin and go to the website, it says welcome to Novacoin. Novacoin is the coin of the future, a unique way of utilizing both proof of work and proof of stake for block generation with separated target limits. Make it stand out. So it is a completely open source. Open source means a community project. Nobody owns it. It's on the blockchain. It is an open source collaboration project. So everything that is inside Bitconnect and in Bitcoin is either open source or a community project where different people from around the world can collaborate and make it better. Okay, so the basis of some of the things that happen within Bitconnect uses the Novacoin ecosystem. Okay, So what this does, this is a way of working out the proof of stake calculator, and we'll see where that goes with it inside the coin. So this is where you can set your difficulty level for your proof of stake, the amount of staking in days, and you go to calculate and it gives you the code that you can actually insert into the system to change your proof of stake algorithm, or to change the workload. Okay, so we can get rid of Novacoin in a moment. So that's Novacoin. Novacoin is actually powering Bitconnect. So that is one of the other community projects that has been incorporated. It's one of the technologies that controls the proof of work and the proof of staking algorithm. Okay, so not many people know that. So that's that. So let's go back out of Debian. We won't go into the Gitian descriptors and the Gitian downloader. Git, this is all to do with repository management and the way that we update the information to actually build the next version. It's a version control version of the Bitconnect here. So you've got wallet tools. So these are all to do with the QT wallet. These are different iterators. Again, it's a JSON RPC. Uses the local proxy and the local IP. And this particular file is for changing your password. So what it's doing is it's expecting, here it says access, so this goes to a function called access.walletPassPhraseChange. This will exist in a different file, and what it requires is password and password 2. So password 1 is the old wallet address passphrase, and the new one, if you want to update it, is password 2. So it says enter new wallet passphrase, and in order to update that, it will expect the first one to be correct and the second one to be correct. And in a different file, in a different part of the system, there will be the logic for actually making sure that this is entered properly on the blockchain, and that everything works, as it should. So you've got those in wallet tools. I imagine that the wallet unlock is exactly the same. So you've got the wallet passphrase and unlock tools. So that is just another one that controls some of the functions within the wallet. Let's go back into the Bitconnect Coin main file. You've got the source files, and this is where the most important part of the actual functionality of the coin itself. So you've got the JavaScript object notation, you've got LevelDB, you've got object testing, so this is the testing environment. You've got all of those repositories that are required to actually build it into all the different versions. So everything's built in CPP, which is C++, and then each one is then converted into a format that can be read by the QT operating system, or the QT system, to actually combine everything into the different distributions for the different operating systems. So all of this here, all these different files, I mean, there's one for Bitcoin. So if you look at the collaborators for Bitcoin, you can see this one was actually written by W.J. van der Laan in 2011-2012. If you go back to the QT area, so yeah, you go through all the QTs. That's the QT software. If you go into LevelDB, so if you want to know what LevelDB is, this is a very lightweight database. So this is the setup for how the database is run and how it logs everything and how it actually makes its own blockchain. So it uses LevelDB. Now LevelDB stores entries lexicographically sorted by keys. The sorting of one of the main distinguishing features of LevelDB amongst similar embedded data storage libraries, and comes in very useful for querying, as we will see later. So what it does, it uses an arbitrary byte array as a database for both keys and values. So it's a key value storage database. That's all you need to know. Okay, so that is how the blocks of data from transaction IDs go into LevelDB. So it uses this LevelDB as its internal database. It's a very lightweight database, and that's why we have this whole LevelDB document here. So it says LevelDB, a key value store. Authors Sanjay Gemawat from google.com and Jeff Dean at google.com. So this is a Google project, and this was used to make key value stores for you searching and everything that powers Google. Most of the key store values are used in the community project that is called LevelDB. Okay, so it's another community, someone else trying to fix a problem to make something better and integrating it into a piece of software. So let's go back to the source code. Zerocoin. Okay, it uses a library for Zerocoin. And you can see there's a zerocoin.h. So what is Zerocoin? Well, you may know that there's a coin out there called Zcash. Zcash is based purely on Zerocoin. If you go to the Zerocoin project, Zerocoin is a project to fix major weaknesses in Bitcoin, the lack of privacy guarantees we take for granted in using credit cards and cash. Our goal is to build a cryptocurrency where your neighbors, friends and enemies can't see what you bought and for how much. Zerocash, the protocol that succeeded Zerocoin, is being developed into a fully fledged digital currency, Zcash. Zcash, this secretive currency, the project that began with a proposed extension called Zerocoin to the Bitcoin protocol that allows users to mix their own coin, a collaboration, this community project that we keep talking about between the original Zerocoin project members and the cryptographers at MIT, the Tech Union and the Tel Aviv University, has produced a far more efficient protocol that allows for direct private payments to other users of hidden value. For disambiguation, we refer to this new protocol as Zerocash. So it goes around the problem of Bitcoin not always being private, because it can actually announce who you are, and it does exist on a blockchain. The whole Zcash and Zerocoin protocol is used within Bitconnect. These are all the definitions for obscuring all of the serial numbers and all of the these libraries to actually make everything completely on the blockchain but completely secure. Okay, so this is an addition to the Bitcoin protocol. So that's Zerocoin. We've looked at that. What else? Key stores. Just saw that there. So if you go to main, we won't look at the key stores. So this is how all the keys, the private keys, are generated and they sit on your PC. The main CPP is the most interesting one, because it tells you how the actual coin is set up. So you can see here the original contributor for main.cpp is 2009-2010, when I used to work for Bitcoin, Satoshi Nakamoto. Okay, it was later the Bitcoin developers, which is now called Bitcoin Core. There were later additions from 2009 to 2012 to this particular file. But if you go down, I know this file intimately because I've built lots of different cryptocurrencies. You can see it actually includes Zerocoin. Okay, if you want to know a precursor to Novacoin, by the way, Novacoin wasn't, it was a follow-on from this, which is PP coin. This is the peer coin, peer-to-peer coin. So if you look at the block numbers, and you can actually see what Peercoin did. Peercoin is a Bitcoin-based cryptocurrency, and is the first known implementation of the hybrid system of proof of work and proof of stake, also known as Peercoin. PP coin aims to promote energy efficiency whilst keeping most of the original and preferred features found in Bitcoin. Okay, so what this is here, this started off Litecoin and Namecoin and all the other lightweight script-based versions, all these different forks from the original Bitcoin protocol. So if you want to go back further from Novacoin, you've got this PPP coin, you've got Zerocoin, you've got LevelDB and Novacoin. So you can see all these different things, all these different collaborators, all these different softwares, all these different libraries being used. So we'll go through this because this is actually quite interesting in this particular file. We won't go through everyone because I'm sure it will actually bore most of you, but you've actually got the CBIG number, the proof of work limit. So this is where you set the limits that actually control the proof of work algorithm and the proof of stake limits. So you've got unsigned integer, n target spacing 2 times 60, block spacing 2 minutes. So rather than say 120 in seconds, to make it easier to adjust, it's 2 star, which is 2 times 60, which is 2 minutes. Okay, minimum stake age is 15 days. So when you look at the unsigned integer n, which is the function stake min age, it is 24 times 60 times 60 times 15. So it's 24 hours in the day times 60, which is in hours, times 60, which is in minutes. 24, which is hours, 60, which is minutes times 60, which is seconds, times 15 is the 24 times 15 is the amount of days, which is 15, and it's the same again for maximum stake age of 90 days, so it's 24 times 60 times 60 times 90, and then you've got the modifier interval, which is 10 minutes, so it's 10 times 60, time to elapse before a new modifier is computed. So that is the Coinbase maturity is every 10 minutes, and the Coinbase maturity produces 50 coins. So it's the Coinbase maturity is 50. So this is how many coins, this is how many Bitconnect coins are produced every 10 minutes. 50 coins. So this is 50 coins produced from the proof of work, not necessarily from proof of stake, because that's on a sliding scale. I don't know if this is going to bore you, most of this stuff, but there's so much in here to see. I will actually put this link in the bottom of the video, so you can actually, if you are interested in seeing some of the other functions and what is included in the Bitconnect coin, everything is public. It is a public collaboration. You know, you can see here what's in here. This is about orphan transactions, how Bitconnect deals with orphan transactions, how it gets over memory exhaustion for different currencies. It shows how it gets through DDoS controls, how it's got anti-hacking security. There's lots of stuff here to prevent DOS attacks. I won't go through every single one. I will give you the link, but just to let you know, there is a very powerful big collaboration. There's a big community that work on this. So when people say, you know, who owns it, you know, who are the people, we've looked at the PLC. We know all the different promoters around the world. We know all the people that are interacting. I imagine that the owners are a very, very small group of people that can be counted on one hand, but the community is massive, and it will always continue, and it is sustainable, because if you look at the mathematics behind it, if you can get behind this and understand it, all the people that are behind, all the people that are pushing it, this is a community thing for and on behalf of the community. I think I've talked too much now, so I'm going to let you guys go, but I hope you enjoyed that. It's a little look, and in the next video we'll be going even deeper, and we will be looking at the Bitconnect trading bot. If you haven't already, like this video, don't forget to subscribe. If you want to know when that video comes out, don't forget to hit the little bell icon so you get notified. There you go, some little bit of a history for you, and a big dive into Bitconnect that maybe you just didn't know. There you go, bringing you some more news every day. I'm Roy Murphy, you're watching the Bitconnect YouTube channel, and I'll see you in the next video.
This video was brought to you by Team Smurf. We bring you new videos each and every day. To join our team, click the referral link below this video. Don't forget to like and subscribe, and interact with us in the comments box below. Bitconnect, creating wealth for everyone.